why it looks like it's not your graph. It's graph. All right, anybody need more time? Okay. All right, so up until this point, you guys have seen vertical asymptotes and horizontal asymptotes. And vertical asymptotes split your graph into pieces, okay? But the horizontal asymptotes have nothing to do with the middle of the graph, have more to do with the ends of the graph. And so yesterday when we were graphing stuff, not yesterday, 2 days ago, we saw stuff like, maybe that, where you have vertical asymptote splits it into 3 parts, and you have this horizontal asymptote, which really only applies to the part to the right or part to the left. That's why we talked about the limit as x goes to infinity. But we could also look at the limit as x goes to infinity. A slant asymptote looks something like this. So instead of a horizontal asymptote, you have another line, but has a slope that's not 0. And so this one is not shown, but has a vertical asymptote right here, so it's split into 2 parts. But as we move far to the right, it's going along this line. So it's increasing, but it's increasing in a linear way. The same thing here. This is a graph that only has a slant asymptote, but no vertical. So that's what we're going to start to look at. We're going to have some functions out of them, and look at how to recognize that they do, and how to graph with them. So number 1 here, we're still going to go through these steps that I gave you. We're just going to have one additional step. And from now on, we're going to have, instead of the 8 steps, you'll have these 9 steps. Okay. So find the y-intercept by plugging in x equals 0. That's kind of our first step. And so we find f of 0, which is going to be 1/4. And then we're going to write that as a point. And most of you guys did that, those of you that turned in your homework. So x is 0, y is 1/4. This is my x-intercept. Box that in. So then our new step is, I meant y, yeah. Thank you. Minus 0.5 points for Mr. Marsh there. Okay. So then the next step, the new step, is to check if the degree of the numerator is 1 more than the degree of the denominator. So we've used degree, that word, before when we talked about polynomials, and degree is the highest power. So what's the degree of our numerator here? So here we got degree 2, and the denominator we got degree 1. And so if our degree of the numerator is 1 more than the degree of the denominator, then that's when we're going to pay attention to this. If it's not, then you just skip step 1.5 and keep going through like we did before. So that's a quick check. Here it's going to apply, so we need to keep going here. So if the degree, if that happens, then we're going to have to divide the numerator by the denominator. Okay? Now, I said using long division because long division will always work depending on what we're having. Sometimes synthetic division would work, and if you know when that applies, you're welcome to use that. But here, I'm just going to use long division to model it, okay? So we're going to divide. Synthetic division would work nicely for you if the denominator is like this. So if it's linear, and the coefficient, leading coefficient's 1. You could use it right now, and if you want to try that, you can do that. But you're going to have to remember long division because most of the cases won't work like this. Okay, so when we do long division, we look at our first term here, the x and the x squared, and we're asking ourselves, x times what is x squared? Just x. And then we're going to distribute that x. We're going to multiply the x plus 4 times that x and place it right underneath here. So we got an x squared plus 4x. And we're going to subtract those, but the nice way to subtract them is to change the signs and add them. We get negative 2x plus 1. And then one more time. And if the degree of the numerator is 1 more than the degree of the denominator, it's just going to be a two-step process. It won't be a very long division. It'll just be a short long division, all right? So how many times does x go into negative 2x? Or what would I have to multiply x by to get negative 2x? Negative 2. So then I multiply all that by negative 2. And actually, at this point, you could stop, and I'll explain why later, but I'm going to finish it. So negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. We need to subtract, so we're going to change the signs and add. So we get a remainder of 9. Okay. So just reading through this, so if there's a remainder, then we're going to have a slant asymptote. We do have a remainder, so we know we're working with a slant asymptote. If you don't have a remainder, it's actually going to have a hole in the graph. Okay. I didn't write that down, but if you want to know that, if your remainder is 0, you won't have a slant asymptote, you'll have a hole in your graph. The slant asymptote will be a line with the equation given by the division here without ignoring that remainder. So from here we can say we have a slant asymptote if you want to write SA, I'm okay with that, at y equals x minus 2. Okay. So if 1.5, step 1.5 applies, skip step 2, because you can't have both a slant asymptote and a horizontal asymptote. You're either going to, I'm just going to say you can either have one or the other, but you could have one or the other, or you could have neither. But if you do, you're only going to have to do one of those steps. You either do step 1.5 or step 2. Now we're going to skip to step 3. Refactor. And x squared plus 2x plus 1. We're looking for two numbers that multiply to 1, add to 2. So 1 and 1. And we can take the shortcut. So this is going to factor to x plus 1 times x plus 1. And over x plus 4. Check if it reduces. If it does, you have a hole. It doesn't reduce here, so no hole in the graph. What's the next step? Find the x-intercepts. So x-intercepts, you take each factor in the numerator, set them equal to 0, and solve. So because you get an x-intercept for x values that make the fraction equal to 0. So they're the same factor, so doing it once is enough. So we have an x-intercept at negative 1, 0. And then last step before graphing is check for a vertical asymptote. So grab the denominator, x plus 4. And we have 1. So, good question. Could we apply what we learned about polynomials, right? Is it going to bounce or maybe not? And I'm going to hold off on that until we get the graph, and then let's talk about that. Okay, so right now, let's say we don't know anything like that, but we might see something like that, and be aware that it might happen. Okay, so I'm going to sketch the graph. There's my y-axis. Y-intercept at 0, 1/4. And the x-intercepts at -1, 0. I'm going to plot those. God bless you. And then we have a horizontal asymptote, a slant asymptote at y equals x minus 2. So that is a line with a y-intercept where? Do you remember how to do this? How to graph lines? It's been a while, maybe. So that -2 is your y-intercept. And you can find that by plugging 0 in for x, right? So it crosses here. And the slope is the number in front of x. So the slope is 1/1. And so from my y-intercept, I'm going to go up 1, right 1, and continue that. So we have a slant asymptote, something like this. And label that. And we have a vertical asymptote at x equals -4. And I'm probably going to have an issue here. I need to extend this a little bit more. Okay. All right. So we've got all the information on our graph that we know, and then the rest of it is trying to figure out what's happening. How many pieces will we have to our graph? 2. Only 2. The vertical asymptote is the only thing that splits your graph into pieces. So we got one piece on the left side, which can happen in the top left, or it could be squeezed in here on the bottom left, right? And then we just have one on this side. So it could be down here, or it could be up here. We're not sure. Well, we do know it's got to pass through these, though, right? So the question is, I'm gonna give some possibilities, and then I'm gonna erase them. So don't write this down. So we could have something like this, right? That's a possibility, or we're gonna have to test it, yeah. Or another thing that could happen on the right side is something like this, right? So those are the only 2 possibilities of what can happen. It's either gonna bounce or it's gonna pass through. And so we need to test something over here. Maybe plug in -2 and see, are we above the x-axis or are we below? And that's going to distinguish, does it bounce or not. So what do we get? So we're going to test, what is f of -2? Going to bounce. So this is going to be a negative number times a negative number over a positive number. And so we're going to end up with a positive value and so it's going to be above. And so we know it's going to bounce at that point. And now we have a reason why it might bounce, because we see in the numerator we had 2 of the same factor. Okay. And then, so that's one part. Don't forget the left side of the graph. You could feel like, hey, I'm done with that, but there's a left side as well. And we're going to need a test point. And here it's not enough to find if it's positive or negative, because we want to know, is it above or below, right? And so we want to actually, what would you plug in for a test point? Yeah. So if it didn't cross the x-axis, so it would, yeah, we would have to cross the x-axis. If we were pointed up here, we would have to cross the x-axis to go down here. So yep, that's, I guess we don't need a test point. Thank you. Saved us a little work. Okay. Okay. So our graph is in 2 pieces. Those are the 2 pieces. Another one. All right, so here's the next one. So g of x equals 8x cubed plus 8 over 4x squared minus 16. So first find your y-intercept. And we get 0, negative 1/2. Then the new step, we check the degree of the numerator and the degree of the denominator. What's the degree of the numerator? 3, degree is 3 here, and degree of the denominator is 2. Are we going to check for a slant asymptote? Yes, because if the degree of the numerator is 1 more than the degree of the denominator, that's when we want to divide using, and here we'll have to use long division. Okay, so try the long divisions, see if what you get, see if the remainder is not 0, you'll have a slant asymptote. If it is 0, then we're going to have a hole. Okay. How do you do the long division? Okay, so here's where you gotta put in placeholders. So the 8x cubed plus 8, you're gonna write 8x cubed plus, there's no x squared, there's no x's, plus 8. So you don't want to skip any of the descending powers there. And then 4x squared minus 16, you'd write 4x squared plus 0x minus 16. And so when we're doing the long division here, all that matters when you start, you're looking at the 4x squared and the 8x to the third, and asking, what do I multiply 4x squared by to get 8x to the third? And 2x right here. And then you're going to take that 2x and multiply it with the 4x squared, the 0x, and the negative 16, and write your answer right over here. Okay. And then you subtract. And we're left with 32x plus 8. All right. So how many times does 4x squared go into 32x? 0. So this is the remainder actually, because if the degree of this is smaller than this degree, then you're already working with the remainder. And so we have a remainder. So this is our slant asymptote. Okay. So y equals 2x. Okay. All right. So next step is to factor. So I'm going to give you I'll give you a couple minutes. Keep working. Work ahead. So for factoring, I factored out an 8 and a 4 first. You didn't have to. That's probably a good way to start. And then x cubed plus 1 is a sum of two cubes. And so I use what we learned prior to how to factor those. So the cube root of x and the cube root of 1 is get x and 1. And then x times x gives me x squared, x times 1 is x, 1 times 1 is 1. And then you use SOAP, right? The same sign, opposite sign, always positive, helping you remember what's positive, what's negative. And then we have a difference of two squares. So we get the x plus 2, x minus 2. Nothing reduces, except the 8 over 4 reduces to 2 over 1. And if you're just reducing numbers, that has no effect on whether there's a hole in your graph or not. It's just, when you get the hole in your graph, that's when you're reducing factors that have variables in them. Okay? So here, no holes in the graph. And then we're going to look at the numerator. When will that be 0? 2 has no effect on it being 0. It's when these factors are 0. So when x plus 1 is 0, and when x squared minus x plus 1 is 0. One of them is easy. The other one, if you look into it, you get imaginary solutions. So it's not going to cross the x-axis there, right? So only one x-intercept at negative 1, 0. And then do a similar thing. When's the denominator going to be 0? That gives you the vertical asymptotes. We have 2 of those. Okay. Questions on this work right here? This is kind of the groundwork before we can start building the graph. All right, then try to graph it. I'm going to show you the final product, but we can talk about why. Okay. So first of all, you should know it should be in 3 pieces. Why does this have to be in 3 pieces? Your vertical asymptotes are what split it into pieces, okay? So you know you should start with 3 pieces. The easiest pieces are actually going to be the far left and the far right. If you look at the far left, okay, you know it's going to have to go along that slant asymptote. Okay, so you know you have to end pointed down. You also know there's no X-intercepts. So you can't cross the X-axis on the left side. So you have to stay below the X-axis, and so that's your only option when I drew there. Okay. On the far right is the same kind of reasoning. You know you have to follow the slant asymptote as you move to the right, and you know you can't. So you need to be pointed up, and you know you can't pass the X-axis because there's no X-intercepts there. So you have to stay above the X-axis, and so that's your far left, your far right. The middle part, there's a couple things that can happen. And that happens at the X-intercept. We're either going to pass through that X-intercept or we're going to bounce. And so we have to pass that Y-axis, so we're below. So the right side here has to point down as it gets close to 2. But the left side, you may have to test it right in here. So maybe test it at negative 1.5. And I don't have that written down here, but if we tested it there, okay. So if we plug that in, we can see if we get a negative value, then we know it's bouncing back down. If we plug it in and get a positive value, then we know it's moving up. Yeah. Okay, so slant asymptotes and horizontal asymptotes only matter on the far left and the far right. It's what gives shape to your far left and your far right. In the middle, you can cross it as many times as you want. That's fine. That's what we had before. You could cross it. Yeah, you can go below it and back up. You're allowed to cross horizontal asymptotes and slant asymptotes. You can't cross vertical asymptotes. Yeah. Any other questions on this one? You want to start on some homework?